Okay, good afternoon, everyone. My name is Angela. I will be leading the training today. Um, so today's training is a little bit different from the seminars that you've been attending this year. So a lot of you probably are all aware, but we've been conducting a series of seminar webinars that was biweekly. And this time, this session is actually a part of the Elite Training Series 2016. It's a continuation of our training series that also occurred in 2015. For the first session, which is for today, I will be covering the wizard modeling of pre-stressed concrete composite girder bridge. And the whole series, you can actually find them on our website. This is the website. In case you didn't know, you can simply type in North America.midasuser.com. We'll always put this link on our invitations too. And once you do, when you actually go to the training and upcoming courses, this is where you are able to see all different topics of upcoming seminars and trainings. As in case you didn't know, we also have speaker seminar series ongoing. That's a part of the Elite Engineer webinar series, and this training is Elite Training Series. And in this training, I'm not really showcasing a project application case, but I'm rather walking you through step-by-step of working using Midas Civil for a bridge application. And today it's going to be for pre-stressed concrete composite girder bridge, and I'll be focusing on the wizard modeling and analysis review. Before we get into the actual part, let me briefly walk you through the composite girder bridge application overall. So either for steel or pre-stressed concrete composite bridge, you could take the wizard modeling approach, or you can manually model these bridges too. So if you have projects both for steel composite girder bridge or pre-stressed concrete composite bridge structure, if you have both cases, Midas Civil can actually handle both them. And what I'll be covering today, right, the wizard modeling approach, it's not specific for pre-stressed concrete composite. So whatever I'm covering today, I'll be briefly showing you the steel part too, but you can actually connect it that you can actually follow the same procedure for a steel composite bridge project too. And also, after modeling your structure using the wizard, either for steel or pre-stressed concrete composite, you can then move on to running analysis and then generating the report for design and load rating check. At this moment, we currently support the design checking and load rating check for ASHTO. For ASHTO, you can actually check steel composite girder bridge, pre-stressed concrete composite girder. You can also check the design for the reinforced concrete pier, including pier cap, so the substructure, or even just like a common, reinforced concrete beam or column, whichever the case is. And you can also check design and optimize design for the cross frames. As of right now, we do not have the design checking or load rating check for Canadian code, but this is actually a great development. We will be updating our design database for Canada code by the end of August 2016. So if you look at this page, the idea you can get is, so if you are already a Midas user, and if you want to learn about how to model pre-stressed concrete composite bridge, you're at a right place today. If you are a Midas user, you've already worked on those things, but if you are not sure how to use the wizard, you're also at the right place because the wizard, we've recently implemented this feature back in January this year. And also, if you're not a Midas user yet, but if you do have steel composite girder bridge and or pre-stressed concrete composite bridge projects, and if you happen to have multiple other programs to handle these two type of structures, you're also at a right place, because Midas Civil, you can actually handle either structure type using the same approach throughout from the beginning to the end. The overview of the training today, it's actually very simple. I try to break down the training so that it's more comprehensive from the attendee's perspective. My purpose today is that this wizard modeling process and how you're able to review the result is as clear to you as possible. But at the same time, I am not going to cover every single very little details that are already covered in the tutorial manuals that are that we distribute all the time. So if you have any further questions, let's say any specific detail kind of remained uncovered during the training, please feel free to let us know by getting back to our follow-up email or even to the invitation email. But overall, so if you look at the top portion, the application flow for pre-stressed concrete composite girder bridge is like as shown over here. You can model using the wizard or manually. It's up to you. But wizard, it can definitely make the process faster. You're not stuck to the wizard template. You are free to make modification after creating the model using the wizard. And you can run the finite element analysis, meaning your results will be very accurate, and also you will be able to examine your result, meaning you're not really you don't really need to be frustrated with the black box design program. And then you can check your design of the beams or the composite girder, and also check the load rating. And this design checking and load rating are performed based on the same model. You don't need to create models multiple times. And this workflow not only applies to pre-stressed concrete composite, but applies to the steel composite girder bridge also, steel plate girder. So the wizard modeling can be summarized into 4 large portions. First, you'll be defining the general layout of it, how many spans do you have, how many girders do you have, stuff like that. What are the sections that you're going to be using? And we also have database for the sections, which I'll be walking you over in the very beginning shortly. And you can define the tendon. This part you can also define automatically or manually. And then as the last part, the reason why I put this part kind of crunched is because they're much more simpler, or they can be done more quickly than the other 3 parts. And then I'm going to walk you through what are the different type of analysis result you can take and how you can simply extract them. Okay, when I get to the wizard, let me actually get to the program for showing you the wizard. Give me 1 second. Okay, so when you have a program open like this, okay, so here where you can first get to is go to the structure main menu, and over here, as I mentioned to you before, today I'll be covering the pre-stressed concrete composite girder bridge, but you will notice that there is a very similar looking wizard right next to it. And then if you also quickly open the steel wizard, this is for concrete, you will notice that the layout looks almost identical, meaning if you learn flow for one, you can apply for the other also. So today you're learning about the pre-tensioned or post-tension composite girder bridge wizard application, but remember, you learn this, you will also learn the other part, and you can easily apply them. And before I get into this portion, I first want to touch up on some of the basics first. So bear with me, give me 1 second. Let's get to the properties first. So I actually want to, very basics about how you can define your section or material. I don't want to bore you with it, but let me quickly mention that when you go to the Prestressed Concrete Composite tab in the section properties, right, under the properties main menu, you can go to the section properties and section tab, and then if you click on add, you will be able to see all different tabs available for defining different type of sections. What I want to cover is that don't spend too much time defining your sections one by one, but very quickly, if you go to Prestressed Concrete I, or if you go to Prestressed Concrete Value over here, what happens is you will be able to see the database, the sections that are already embedded in Midas like this, right? And whenever you see these databases, it also means that you can apply the straight tendon strengths automatically. And if so, open here to find the proper database you want. And also, don't miss this part. Not only for the Prestressed Concrete I, but if you go to PSD value also, go to the section data, click the DB, you will be able to find more extensive data over here. Even the box beams, or like above T or new sections, or void box sections, you can find this type of different state database in Midas level. And whichever ones you do not see yet, meaning we are continuously enhancing our database, but if you not yet are seeing your state section, you can actually import those sections from the CAD to section property calculator tool, and then import it to over here. We have a separate manual for it. Please feel free to reach out to us for how to do that. But today, let's focus on the wizard modeling approach. So what I'm going to do here is I'm actually going to open one of the models that I provided to you already. You may not recall, but in the training invitations, I actually provided the technical materials in advance. If you happen to have, if you have Midas Civil installed, if you have the models downloaded, please feel free to open them with me. And I'm actually going to mention to you when is the proper time for you to actually follow, because I don't want you to be paying attention to every little click that I make. I'm going to specifically give you directions when is a good time to follow so that you can actually see the effect of the wizard, right? So right now, if you're ready with the materials, open the program and open the model file. The model file that I just opened is 0831 precast underscore 2span underscore default, right? 0831 precast 2span default. And if you just open this one, if you take a look at the tree menu on the left, you'll notice that I put in the very basic properties, to save our time. They are, if you look at them one by one, they are like the materials for the girder or for the deck portion, and they are also the composite girder sections, not this one. So this, I girder section is predefined. So let's go to the Prestressed Composite Bridge wizard. Again, it's under the structure main menu. And from here too, this is where you can also follow. So after opening this model, right, go to open here, and then go open one of the wizard, right? And let me walk you through the wizard very briefly. So if you look at it, the layout where you can define the overall geometry of it, right? Here, when you first come to it, you're able to define which type of girder you want to work with. Is it precast or splice girder? Meaning, you know, when even if you regardless you have a simple precast project, or you have a little more complex splice girder project, it doesn't matter. As long as you are into this wizard, you're set. If it's very simple, if you already know your very comfortable way of working with it, fine. But if you need to use multiple tools for, you know, splice girder, let's say, in Midas, it's simply a matter of defining the girder type and kind of walking through the rest of the layout, you know, as the wizard kind of, you know, naturally guides you to. And also, you can choose the modeling type between all frame or modeling the concrete deck using plate. Span information, this is where you can define how many spans and how long the spans are, like that, right? And also, okay. And you can also move on to see the total deck width is, you can define them over here too. And here, the spacing A and B, right? So the spacing A is like the distance between the actual girders before the concrete is poured. And the spacing B is like the gap between where the bearing is located to the end of the girder, so that, you know, this little leftover part is reflected in your analysis and design check. And this also means that before the concrete pouring, the dead load at the non-composite state or in the non-continuous state, right? So when you extract your non-composite dead load result, it means that, you know, the results are based on the non-continuous, you know, simple span condition. And after the pouring happened, then this gap will be filled so that the bridge is continuous in case it's a multiple span program, right? So that's what the spacing A and B are for. You know, detail, something detail, but then some programs are not able to handle this. And also for clarification, I had a few notes. To clarify, you know, the section and the material properties are not saved in the wizard file, but they are saved in the base model of Midas civil file of an extension MCB, right? So that the wizard, with the wizard, I opened the wizard file for you before. What the data will be brought in are like the inputs that are put in the wizard, right? And then the section and the material, you can define them, or you can open a base model, or you can actually import them in the middle of using the wizard. Just wanted to clarify that before moving on. Okay. Okay, and yeah, I actually have multiple questions coming in, but you know, just to kind of keep the flow of it, please excuse me, but I will definitely come back to all the questions, you know, after covering this page of the wizard. Okay. And then after defining this type of this type of geometric layout, you can move down to the substructure portion. So this part, right? So it's a little bit different from the conventional design program. So you will have to come with certain geometry layout when you come into the wizard of Midas. And then when you get to the boundary and substructure, this is the part where you can define the structure without the substructure or with the substructure, right? And this is where, you know, it also the design for the pier and pier cap comes in useful, because here if you actually model with the substructure, right, the pier and the pier cap will be modeled by the wizard, right? And then that means, after modeling, you're not only modeling the superstructure, you can also model pier cap and pier, and you can also check the design for them. We also, the part that I'm covering right now, right, we have training materials, tutorial manuals in the PDF format, and also for the design of the pier cap and pier. So, in case you want to cover all the details, no worries. Please pay attention to cover, to fully understand the flow of it today. So this is where you can specify the material. Number 2, for pier cap section, pier cap section. And for the column, we're using the column section. And these were, as I mentioned to you before, predefined and saved in the base model that I opened at the very beginning of demonstration. Okay. And then you can move on to the section tab, right? And the section here, you can define your deck thickness, define the material for the deck, girder, concrete each, right? Define the number of girders, right? And what are the distance between them by defining the offset, right? And after that, you can also define your diaphragms. Diaphragms, it's very simple. So basically, you can just define, like a sub, like a middle or like the end cross beam. So it's very simple, just a rectangle section. And let me actually show it to you after running the wizard, how they come into a part of the real structure model. You can define their location. If you do not have any crossbeam, minimize defining them. Let's say 1 or 2, so that you do not need to you do not need the crossbeam in your actual model. And then you can get to the girder portion. For the precast, it's very simple. For splice girder, composite bridge, it's a little more complex, but we'll also get to that one. But for precast, more than 90% of the time, it's just one girder section. So you can simply pick, most likely it's division of 1. There's no division for girder for precast in most cases. So you can simply pull the type of girder for span 1. Also simply pull the type of girder for span 2. And then, now you're done with the section portion. Then you can move on to the tendon tab. And the tendon tab here, you can actually define different type of harp 2, or like the curved type of tendon using this section. However, don't be overwhelmed yet. If all of the straight ones, right, you can actually automatically import them according to the database, the section database from ASHTO or your DOT. So remember, the sections that you already saw the database for, you can also pull out the tendon for these sections. Not over here. We can get to it in a little second. But this part, if you need to define any of the hard or the curved, or if you are okay defining them a little more manually like this, this is where you can use them to define how many strands, 12, right? If I shrink it to 10, you will notice that so as you change the number, you'll actually see the changes in the drawing like this. So after you change them, you notice the change over here like this. So it's a real-time data with the drawings. And after defining the whole set, you can actually link it with the jacking stress, right? If it's also, if you also need to consider grouting, you can actually define, after actually casting this, how many stages after do you want to consider grouting? And you can actually simply add it as a part of your tendon assignment list, right? So, and then it's going to actually let you know how many tendons are there in total so that you can quickly overview each tendon group you defined. And when you get to the loading portion, this is very straightforward, very simple. If you have if you just click the loading you want to consider and then type in the loading value, the wizard will automatically apply the weight for it. You don't really need to convert the loading data for wet concrete and the wearing surface. You don't really need to convert it per girder weight. You can simply input the weight of the concrete and the thickness of deck. The program will take care of distributing and assigning the uniformly distributed beam load. And then you can also go to the construction stage. For the precast, I don't want to get into, this is a very simple process. And also for the precast, there's not much staging we really should consider. So in this case, by default, the program is going to erect the substructure first. It's going to erect the girders, right? And also diaphragms, the temporary or the permanent diaphragm. And then the deck is poured as the loading first. And then the deck actually comes in to be permanently settled above the girders. And then after composite loadings are activated and the long-term effects, creep and shrinkage, can be also considered in the last stage. And all these staging, right? If you happen to use simple design programs for precast bridges, it may sound a little more complicated, but if you know that wizard will take care of setting them up so that when you go to the design checking, right? In the design checking, the program will automatically extract the forces from the non-composite state properly. It's also going to extract the short-term composite result from the stage 4, or if it's different case, because there are more stages, it's going to extract the result from that stage properly. And for considering the creep shrinkage effect, it's also going to extract the result from the last stage. So that's an overall composition of the wizard and how you can also create your bridge model like this. So once you are done, you can actually say OK. If you want to save your data, you see the Save As button over here. Just like how I opened the wizard data before, in order to be able to pull your current or past data, you just need to save this wizard data as a file. So whenever you want, you can actually quickly pull it out like this. So here, if you look at it, give me 1 second. Just want to quickly give a variation of color so that it's more clear to us how the model is defined at the moment. Okay. So do you remember the information that I put in the wizard? 2 span and total 6 girders. And then notice the tendon profile also. These are all straight ones. If you want, you can also go to, use the wizard template for simply defining harped or curved ones. And if you look at the workstream menu over here, you will notice that all different data are registered in the workstream menu, meaning the wizard just created these data over here. Okay, and the flow that I just took before, it's actually the same exact process you can take for steel composite plate girder bridge, and also for spliced girder composite girder bridge. And let me very quickly open the splice girder example. This one hasn't been covered in any of our trainings yet. I'm not going to cover all of the details and take up the time, but then I want to point out the major differences between the precast and the splice girder after you choose the girder type in the very beginning. So if you actually choose the splice girder type, right? One of the major difference is when you go to the section part over here, now you can actually define the splice point. Before, for the precast girder interface, we didn't have the splice girder point, we couldn't assign it, but then when you actually choose the spliced girder type in the layout over here, when you go to the section, it's slightly changed, just the girder portion. So everything else remains the same. How many girders you have, how far apart are the girders are, and also, what is the material assigned to each part. And then, but then the main difference between the precast and the splice here, you can simply check on the splice point to be able to distinguish, to let the program know this is where the splice point is, right? So here, if you look at it, I'm defining my section, girder alignment to be symmetric about the center of the girders along the entire bridge length. So I checked on the symmetry option, right? And I have total 7 divisions. If you look at my diaphragm and girder information, you will notice that, for this example, I currently have 3 spans. So if you look at it, I have the drop-in sag approach portion here, right? And I have the end portion here, and the end portion, at the end portion, I have a splice girder point, right? And also at the next splice girder point is at the end of this TPD segment. Let me actually open the model and kind of help you connect with this. Give me 1 second. Okay. So let's try to connect the splice girder point input with this one, right? Let me just activate one segment so that it's easier to understand. Okay. So if you look at it here, remember the name of the sections before? The end segment. Remember? Right? And at the end of the end segment, we had a splice girder point. Remember? Give me 1 second here. So at the end of the end segment, I defined the splice point, right? And at the end of TPD segment, I also defined the splice point, right? So it's the splice point here and here, at the end of the drapes. So when you go to the model here, I have the splice girder point here, and then I have TDI and, TPD section. Meaning, this is, like this, the girders with varying depth is defined, and then the other part too. And then originally we had our splice girder point right over here, right? And now at the end of TPD, we also have a splice girder point. So we have a different splice girder point, like 1 and 2 here. Makes sense, right? So when you actually look at the stage effect like this, okay, so these, above the super substructure portion came in first, and then, you can also erect the end parts, and then you can also erect the, like the very last portion. And this erection sequence, right now, they are simulated to be symmetrical. If you need to, you can sequence them so that, one span comes in first, and after how many days, the the next span is erected and so on. So, but then basically, if you set up your model using the wizard, these type of sequencing, considering the splice girder point, will be managed using the wizard. So that's what this the girder information part is about. And then if you look at my section list, I only have 7 sections, while I had total 7 segments in this one, right? Remember? So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, right? But I was able to define it only with the 4. Of course, it's a different story when the when the structure isn't symmetrical. But that's how quickly and easily you can manage the splice girder point. But you don't need to go through this headache if you are just working with your precast composite bridge, since it's a lot more simpler. And the same way, you can have the tendon. One of the very common question I get is, when it happens to be a, if one of the very common question we receive is it possible to combine, pre-tension strands and also the post-tension strands? The answer is, of course. So basically, if you look at this one, how this one is defined, right? If you look at it, I have segment 1, 5, 2, 4, and 3. So I actually segmented them in different way. Like for the taper portion alone, for the end part alone, and also for the middle part alone. So for different type of segments, right? And segments, you can actually define them flexibly over here, but most likely, it's actually very similar to this tutorial case. So if you happen to have this application, it's a matter of comparing this with your case, but you can basically follow how this one is set up. And I was able to combine the pre-tension strands and the post-tension strands by doing it like this. So all the segment pretensions, right? The strands that are already embedded before they come to the site, or on site, but in the segments, you can define them separately. But for the post-tensioning, for linking all of the girders, I actually put all of the girders into the all segment, right? And then I defined the post-tension. And then the way I was able to define a post-tension by, defining the post-tension tendon property. So, and then I actually added them all into the tendon assignment list, meaning segment 1, 5, these are for the end segments, 2 for the taper portion, 4 also on the other span, and 3 for the middle span. All this, and for the entire bridge length, this post-tension and pre-tension combination can be defined in this tendon tab. The loading, it's actually the same as steel, or, because this tab is only for the dead load. Pretensions, they are considered in the tendon tab here. And when you come to the construction stage, you can also easily use the template, over here, that's already optimized for the splice girder bridge application. So, just click the guide. Feel free to refer to, the natural sequence of the splice girder construction, substructure erection, the, erecting the precast segments, right? And, again, if they are in different order, it varies span by span, feel free to reflect that also by using the customize window here, right? And then you will cast splices and make them continuous, and then perform the first stage of post-tensioning, right? And finally cast the deck. And then if you want, you can also perform second stage post-tensioning. So I'm also expecting there may be a question as, can you post-tension in sequences? You can also get the answer over here, yes. And then as the last stage, you can remove the temporary supports and place the barriers. And this is actually all set up in the table here. And if you want to, modify them, feel free to use the interface here for customization, right? For temporary support position, you can define them. You know, this is where the endpoints of the segments are. So, and you can also specify which one is the post tension. So remember I mentioned to you that you can post tension in sequences. And before in the tendon tab, we defined post tension 1 and post tension 2. They are almost identical, but with they are independent post tensioning. So if you just choose them, right, you can actually define it as post tension 1, the first post tensioning, and then post tension 2, the second post tensioning. So you can easily use the construction stage setup over here, right? And once you hit on OK, you will get a model generated like this exactly. And you'll be able to see that wizard actually follow the sequence of, for if it's precast, it's going to sequence it according to the precast construction. If it's a splice girder, it's going to automatically follow the sequence of a the splice girder construction. And while I run the analysis real quick, let me briefly kind of walk through some of the questions for a couple minutes. Okay. There was a question, if the bridge is a combination of spliced and precast girder type, how should we manage this? If you're able to kind of explain a little more about, if it's a case when, one part of the bridge is spliced and it's just connected to precast girder part of the bridge. If it's a case like that, so like the two different part of bridges are kind of independent, but just happen to be connected. If it's that case, or are you referring to having the precast girder and post tensioning in the end? If you can kind of elaborate that, that will be very helpful. And the A and B input that are different for span by span, let me real quick double check. But this part is actually fixed for multiple spans. Yes. So actually, so if you want to kind of make a difference though, remember in the workflow of a precast, right? There's always, you're not limited to the way the wizard create you the model. So the wizard is built to be most comfortable and simplest, not really, distracting you for, more than 90% of the cases. But if you happen to have a case where, details like A and B are varying, over here, right? Then you can always, create a model first, and using the manual, node and element, move node, this type of functions, you can actually really easily, you can kind of tweak that. I'll follow up with you personally to kind of give you a little more detail about it. Oh, yes, and I also have a question that is the wizard able to handle, a case where the bridge goes from straight to the curve mid-length? Yes. So basically, if you go to the multi-curve option here, this is where you can handle that. We also have an example of how you can manage this multi-curve. We actually have an example where the bridge goes straight and then curve in the middle. So I will also, share this with you. And I think I answered one of the question also. Is the wizard able to handle continuity post-tensioning of splice girders? As you saw before, you can freely define different segments, and also you can put the entire girder length into the segment group, right? Defining as, the entire length group, so that you can define the post-tension. This question is answered already, so you can define continuity post-tensioning of splice girders. You can distinguish one end and both end jacking also, yes. And those details, right? Those details, you can actually handle them. You can actually handle them when you define them in the wizard or outside of wizard. You have all the flexibility, even after you work in the wizard, you're free to actually come out and alter them outside of the wizard. So basically, yeah. And and radius in the layout, this is actually referring to the radius of the reference line, right? So it depends on where you assign the reference line to be. So that's what the radius is for. Depending on where your reference line is, how the radius is defined for you, you can actually bring in the data according to your project. I have a question related to like abutment wall and soil structure interaction. Since that's actually not a part of the training scope today, that information will be rather provided in the follow-up. And you can also define super elevation. That's actually notated here as bank rotation. So the super elevation of the superstructure, you can actually define over here in the bank rotation. Yes. And this one, since you can actually define it by the station, you can actually have it vary along the curvature of the bridge. You can, of course, create the bridge overall with the large configuration using the wizard, and then you can modify the elements as necessary. Yes, let me get to this portion real quickly. And also, when I want to show you how you can review the result before we have to end the training already. So let's say you already completed working with your model like this, right? And let's say you kind of need to modify something. If it's something related to the length of the bridge, or if it's related to the size of the section, no worries. The element length, the bridge, let's say. So let's say what will be a very good example? Let me give you a quick example like this. So if you happen to need to modify any of your node or element information, right? Yes, you have free access. You are free to access your node table and the element table like this, and you can always modify them as you need. So they are blue colored, right? Meaning you can always modify them. And these gray sections cannot be modified, so you can always modify the blue cells. And this one, a lot of our users, if you happen to attend one of our training, you probably, the past seminar training, you probably know Michael Roberts from HDR, he's also covered this. Midas Civil has really good compatibility between Excel and the tables itself. So if you simply copy this data and then paste it into Excel, and let's say you kind of modify anything, you can simply copy in the Excel data and bring it to here. So you can just simply modify the data like this. It's actually a very common approach that many of our users take. After creating your model using the wizard, you have full freedom to modify any of the data you need. In terms of the section 2, let's say you define something and you need to kind of modify something after. You can always go into the properties here, and let me actually modify one of the Girder section to make it really easy to you can easily see. So here we have the Girder section defined, right? I want to kind of show you how you can, change this. So let me just make a very odd change, and let me just say, okay. Oh, give me 1 second. Now we can do this. Yes. Okay, this change. Okay, so after, if you want to, you can actually change your section data even after you run the wizard, right? To kind of make it different from what it was before. And this applies to not just changing a dimension of a section, this applies to changing the entire section from ash to 3 to ash to 4, or from one of your DOT section to a different DOT section. So if you just define different section, you're able to kind of run the wizard data over it as many times as you want. Okay, and let me get you to the analysis result portion. So after you run the modeling, right, actually are a couple steps that I omitted up to here. So when you define your wizard, there are a couple more things that you need to do. And one is defining your creep and shrinkage, right? So for the concrete bridge, we'll need the creep and shrinkage effects. You can actually define them using the built-in database in Midas. Midas actually has, CBFIP, most commonly used for, time dependency of concrete, especially for prestressed concrete composite bridge. You can define according to the database, and the notational size of the member. Here you can actually define them arbitrarily because the program, the program can actually, because this notational size of member, it varies along the bridge, right? If you have different sections at different part of the bridge, it's going to vary. It's difficult to kind of control all of them with one number. So later I might take you to somewhere you can actually have the program automatically calculated. And once you set these things, you are also free to check the actual function that are built based on your input, which only requires like one number, pretty much. The characteristic compressive strength of concrete after the 28 days. And you can also define your compressive strength, right? And then as the very last part, you simply need to link it with your the concrete material you used, especially for the girder and for the concrete deck portion. Okay. And where I mentioned to you that you can automatically update the long-term the notational size of the member. So when you go to here, right, you will notice that for each composite section that are used in the model, you will notice that there's H, and if you're using let's say H2, you can input the volume surface ratio. But here we have H for CBFIP, right? And this number, the program actually will automatically update it if you just use this update all H option here. Yes. And then for the age of the girder, I'm going to put 28 and 7 so that we can reflect the hardening of the girder and the concrete deck each. So the age 28, because we want to see the girder effective with the strength at the 28 days, right? After it's cured and erected. And for the part 2, which is the deck, we want to see the effect starting from, let's say, like 4 days or so when the false works are removed. That's why the age is updated like this. So this time dependency is something you kind of need to come back to after defining them. And you need to update all age, for the creep and shrinkage. And they are, when you actually go back to check it, you'll notice that the age parameters are updated automatically like this. If you're using a long-term creep and shrinkage that requires the volume surface ratio, you will go for the update long-term. This one will automatically update the volume surface ratio, update all age, will update the age, the notational size of the member over here. So you don't need to worry about computing those things for each different part of the section and things like that. And you can run the analysis and actually thank you for the correction. And yeah, after running the result like this, you can go to the result. For actually the time being, I won't be able to, today is the first part in which I covered focusing on the wizard modeling. And in the next section, what I'm going to do as a part of the elite training session, the second session following up will be about the design and the load rating check. And as a part of the design and the load rating check, what Midas Civil is doing, so basically after creating your model like that, and when you go to the design or the load rating, actually for prestressed concrete, you can go to here. So here, you can actually perform the design checking for either composite or non-composite. It doesn't matter. Whichever case it is, if it's prestressed concrete composite structure, you can actually perform the design checking and load rating. And as a result, you will be able to get a Excel report like this. So if you look at it, you can actually see a summary of your design condition, section properties, materials that are actually put together in a presentable format. And this part is what I will be covering in the next session. But the next session is actually in May. If it's difficult, if you are actually working on a project that you wish to see the material sooner, we actually have a pre-recorded one as well. So feel free to reach out to us to ask for the materials related to it. And any of the questions that are more specific and and technical support related, when you go to our website, we are also trying to actively promote our new website. We've fully renovated it so that in the very near future, you will also have your PDH certificate bank. But when you go to the training and when you actually go to the support, you're going to see the technical support service tab. And this is where you can see different type of services available. For the users only, you can actually ask us one-to-one specific questions through the web board. But please note that this service is only available for our users. So in case you're not, hope you can become one in near future. And thank you so much for your time. Any of the questions remained unanswered yet, I will be following up with them. And yep, hope to see you again in the second session. Have a great afternoon all. Have a good day.